In this third video on the naming of alkanes, cycloalkanes, and alkyl halides, we'll take a look at the use of some common names, and we'll get into the naming of cycloalkanes. We'll start off here with looking at these alkyl halides and common names. When we have particularly simple alkyl groups attached to a halogen, for example a methyl group or an ethyl group, we often use what we'll call a common name in place of the systematic name, and IUPAC generally allows this. So to use these common names, we say the name of the alkyl group and then the name of the halide ending in IDE. So for example, here we have an ethyl group attached to a bromine, so we would name this ethyl bromide. Notice it's almost like you would name an ionic compound, sodium bromide, potassium bromide. We're just here using ethyl as if it were a cation, so ethyl bromide. Note the systematic name would be bromoethane. Here we have methane substituted with an iodine atom, so we would call that methyl iodide. The systematic name would be iodomethane. And finally, T-butyl chloride is quite a bit easier to use than the systematic name 2-chloro-2-methyl-propane. If we have a chain which is 3 or more carbons long and we use it in a common name, we precede the name of the chain with N. We don't use N in systematic names. So for example here we have a propyl group, and as a common name we'll call it N-propyl bromide. If we were to use the systematic name, we would call it simply 1-bromopropane. There's no need for an N in there. And if propyl was a substituent in a systematic name, we would not use the N. So here's N-propyl bromide. Here we have a 4-carbon chain N-butyl iodide, and here we have a 5-carbon chain N-pentyl chloride. Notice these would only apply, of course, if the halogen is bonded to the last or first carbon in the chain, depending on how you look at it. Now we'll move on to naming of cycloalkanes. Cycloalkanes simply have their carbon atoms arranged in rings. We will not, for the time being, include benzene rings, but we will look at naming those in a later set of videos. So we name them by simply looking for the parent, which is the number of carbon atoms that are in the ring, and we precede that name with the prefix cyclo. So here we have what are the most common of the cycloalkanes: cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane, and cyclooctane. The naming of cycloalkanes is quite similar to the naming system we've already seen with looking at acyclic alkanes. And by acyclic, I simply mean compounds which do not contain rings. So if we have a single ring present in our compound, we define that ring as the parent hydrocarbon. And any groups which are attached to that ring are substituents. So let's take a look at some examples. Here I have a cyclopropane ring. The cyclopropane ring is considered the parent hydrocarbon, and the chlorine atom which is attached is the substituent. Over here we have a cyclohexane ring. It is the parent, and the ethyl and methyl groups are substituents. It hasn't always been the case that when determining the parent hydrocarbon we simply looked at the cycloalkane. It used to be that when trying to determine the parent hydrocarbon we would look at the longest carbon chain that was present in the molecule, generally as a substituent on the cycloalkane, and compare it to the number of carbons that were in the ring. And if the longest chain had more carbons than were in the ring, we would designate that chain as the parent hydrocarbon. Now the rule has been fairly recently revised. I believe these were the 2013 naming rules. But the problem is you will still see names which follow those old rules. So let's take a look at this example right here. Using the older rules, the parent hydrocarbon would have been the pentane here, simply because it contains more carbons, 5, than are in the ring, 3. Under the newer rules, we will always designate the cycloalkane as the parent hydrocarbon if there is just one cycloalkane. So in this case, the parent would be cyclopropane, and this pentyl group would be considered the substituent. So we're going to look at naming the cycloalkanes according to the number of substituents that they have. If we have one substituent, naming is quite easy. We simply say the name of the substituent and then the name of the cycloalkane. There is no need for a number 1 because it's simply understood that the substituent is on carbon number 1. So the name of this compound would be simply chlorocyclopropane. And if we were ever talking about the compound, we would say that the carbon which chlorine is bonded to is carbon 1. And in this case, we have ethyl cyclohexane. If there are two substituents, it becomes a little more complicated. So if the substituents are different, we're going to have to decide which one comes first by simply using the alphabet. So whichever one comes first alphabetically is assigned to carbon number 1, and then we number around the chain to give the other substituent the lowest possible number. And then, just like we did with acyclic alkanes, we list the substituents in the front of the number and precede those by their carbon number or locant, and then we say the name of the cycloalkane. If the substituents are the same, we assign one of them carbon number 1, and the other one we number so as to give it the lowest possible number. And then we say the name of the substituents preceded by their locants. And of course we have to use di in front of the name of the substituent in that case. So let's take a moment and name these compounds. So let's begin with this compound off to the left. Our ring has two substituents on it, a methyl group and an ethyl group. Alphabetically, ethyl comes first. So I will give it carbon number 1. And if I try to number going counterclockwise, I get to the methyl group in carbon number 3. If I went the other way, it would be carbon number 4. So this is the preferable way of numbering. So the name is going to be 1-ethyl, 3-methyl. And then we state the name of the parent hydrocarbon, which would be cyclopentane. In the next case, the substituents are on carbon number 1, no matter how I look at it. So this is simply carbon number 1. Iodo comes first, alphabetically, then methyl. So the name of this compound is going to be, let me go ahead and put the name above the ring here. So it's going to be 1-iodo, (1-methyl), and with 4 carbons in the ring, that will be cyclobutane. In this last example, I have the same substituent occurring on the ring. So there's 2 fluoros. I'm going to number in such a way as to give me the lowest possible number. So I'll make this number 1, 2, 3, 4. And it should be clear if you'd numbered the other way, you would have gotten 1, 4 as well. And there are 7 carbon atoms in this ring. That's going to make the parent cycloheptane. So this compound would be 1,4-difluoro. Careful on spelling here. FLUO. And then cycloheptane. Finally, we look at the case where the cycloalkane has 3 or more substituents. So what takes primacy here is giving the lowest possible numbers going around the ring, principally to the first 2 substituents. So we want to number in a way so that the first two substituents have the lowest possible numbers, and one of those will be carbon number 1. And then you want to proceed numbering in that same direction so that the third substituent gets the lowest possible value. And if there were a tie, you would continue on so that the fourth substituent had the lowest possible number. If there is a tie, and that's fairly rare, we break it using alphabetical order. And then we end the name with the parent hydrocarbon, the cycloalkane. So let's take a moment and name these 3 compounds. This first compound contains 3 methyl groups on it. So in deciding which of these is carbon number 1, I'm going to pick this carbon right here, because then the second methyl group will also be on carbon number 1, so it'll be 1, 1. And then I'll number counterclockwise to make the final methyl group appear on carbon number 2. So this has a parent of cyclopentane. The name of this compound will be 1, 1, 2 trimethyl cyclopentane. Let's look at the next compound. So you'll notice at the bottom I have 2 substituents on adjacent carbons. So my choices will be to have this either as 1, 2, or have the bromine as number 1 and the ethyl as number 2. But as you'll see, we now want to get to the final substituent so that it has the lowest possible locant. And that would be going in the way that I've already started to number. 1, 2, 3, 4. And so there are 6 carbons here. Let's list our substituents alphabetically. So we have 2 bromo, then 4 chloro, and I'm going to go on to the next line here. So 1 ethyl, cyclohexane. You'll note that if you need to continue a name onto a second line, it is okay to put in a hyphen, so long as it's after a syllable, even if it wouldn't be normally where we would be allowed to put a dash. For example, I could have continued the name 4-chloro-1-ethyl, put a dash, and moved on to the next line, cyclohexane, even though technically there should be no dash between ethyl and cyclohexane. If we look at this last compound, no matter how you're going to number it, it's going to come out as 1, 3, 5. And in that circumstance, we give the bromine the carbon number 1 because it comes first alphabetically. And then choosing between chlorine and iodine, it'll be the same number either way. So again, we're going to use the alphabet and number towards chlorine, which comes first alphabetically, and give iodine carbon number 5. So this compound is 1 bromo, 3 chloro, running out of space, so I'll go to another line, 5 iodo, and again, cyclohexane. These final 2 slides summarize the rules that we have been discussing in this video and the previous 2 videos. Let's start off by naming alkanes which do not contain a ring. The first thing that we do is identify the parent hydrocarbon. You'll recall that that is the longest carbon chain present in the compound. If there happen to be two longest chains with this same length, we choose the chain that has the most substituents. We then go to number the chain, and we want to number the chain in such a way that we get to a substituent in as few carbons as possible. In other words, we would like that first substituent to have the lowest possible locant. If, in numbering both directions, we end up giving the first substituent the same number, then we continue on to look at the second substituent and try to get it the lowest number. If that doesn't break the tie, we continue on to the third substituent. If, after this whole process, we still have a tie, then we resort to using alphabetical order, and we want the first substituent that we encounter to come first alphabetically. Finally, we name the compound by listing the substituents first in alphabetical order, preceded by their locants. And if the same substituent occurs more than once, we're going to be using prefixes like di and tri, tetra, etc. And then we end the name with the parent hydrocarbon. Notice that we do not use numbers or locants for any kind of a substituted methane or for ethanes with only one substituent. So, for example, instead of using 1-iodomethane, we would always just call the compound iodomethane. And the same would be true for 1-iodoethane. It would be simply iodoethane. We would need to use numbers if there were two or more substituents on an ethane. The grammar rules are to separate numbers and letters with dashes, and we separate numbers from each other by using commas. And we make sure not to add any additional spaces between letters. Now let's look at the rules for naming cycloalkanes, which are similar. So the parent hydrocarbon is simply the number of carbon atoms in the ring, and we precede that by the prefix cyclo. If the cycloalkane has one substituent, we say the name of the substituent, and then follow that by the name of the parent hydrocarbon, which is the cycloalkane that we're dealing with in that case. We don't use a number or locant. If the cycloalkane has two substituents that are different, we want to give the one which occurs first alphabetically the number 1. And then we continue numbering so that the second substituent has the lowest possible number. List the substituents in the beginning of the name, preceded by their locants, and then state the name of the parent. On the other hand, if the substituents are the same, we assign one of them to carbon 1, and then number around the ring to give the other substituent the lowest possible number. Again, we state the name of the substituents at the beginning of the name, preceded by their locants, and then the name of the parent. Finally, if a cycloalkane has 3 or more substituents, we number the substituents so that the first 2 have the lowest possible number. And then we continue on so that the third substituent has the lowest possible value. And if we need to, we continue on to the fourth substituent or the fifth. If there's a tie after this entire process, we resort to using alphabetical order to break that tie, and end with the name of the parent hydrocarbon. In the next video, and the last one in this set, we will be looking at complex substituents. Thank you.